All right, Algebra Half. Lesson 43 is called Multiplying and Dividing Mixed Numbers. If you take a look at this first one right here, I have an improper fraction and a mixed number. And I'm not sure how you would want to attack that if you left it as it is. It wouldn't be easy. Unlike with adding and subtracting mixed numbers where we attack the whole numbers, then we do the fractions. With multiplication, we generally like it to be in this improper form. So we're actually going to change this so that it's not 4 1/3, but 12 plus 3, or plus 1 is 13 over 3. And then we'll multiply our impropers. 6 times 13 is, well, let's, before we do that, right, make our jobs easier. Watch always for canceling. Divide both these by 3. Can't do that one. Now, final answer. 13 times 2 is 26. 1 times 5 is 5. Can I reduce? No. You can convert this, right? What's its mixed number? 5 goes into 26 5 times, leaving me 25. Difference between 25 and 26 is 1/5. Which one's more right? At the top of 143, I think they have a great note there that's really interesting that tells us that in arithmetic we generally like the mixed number, but in algebra we generally like the impropers. And the book is going to use both here and there, so just neither time is more right than the other. If a student uses one or the other in their answers, just check, try converting it, and if it comes out to the right thing, then give them the credit. Neither one is more right. Sometimes switching to mixed number, what's the advantage? It's easier to tell if you're reduced all the way. Sometimes impropers, you don't reduce. So that might be an advantage to the mixed number arithmetic style. So if we look at these three mixed numbers, we're supposed to multiply, right? These are meaning multiply. What do? We convert. This is a 4, sorry, times 2 plus 1 is 9 over 4 times 10 over 3 times 61 over 12 is what all of these are improper. Can I do any canceling before I get started here? Absolutely. Divide these by 2. Divide these by 3. Whoop. And divide across, I think we can go divide by 3, divide by 3, like that. So now I've got 5 times 61 is 305, and 2 times 4 is 8. All right, 305 over 8 cannot be reduced because we canceled well. We could convert this into a mixed number, but it looks like unnecessary work. If we canceled well, we don't need to deal with that. Final answer. See, we converted, we canceled, we finished. Now, what operation is indicated by the fraction bar? You remember? It's division. So I'm dividing 4 1/8 into 2 1/5 pieces. Not sure where you would do this in real life, but we can solve this in arithmetic. And the way we're going to do it, as we did with multiplication, the inverse operation, will be to convert these into impropers. So we're going to do 33 over 8 over, and I know this looks really messy right now, and you might think, this looks harder now. It's not. We can do something with this, right? When we divide by fraction, how do we divide? We actually flip this into its reciprocal and we multiply. So I'm going to write that down here. 33 over 8 times, don't forget to flip it, that's the biggest mistake, 5 over 11. Ooh, this looks nice. Divide by 11 for both. 15 over 8 is my final answer. Why don't you pick one multiply and one divide from the practice problems? Show me good work for both.